Here's another algebraic identity. We could simply memorize it, but we need to understand what these concepts mean if they're going to be of any use to us. Again, we're working with quantities a and b, which we can visualize as line segments. To create the idea of a and b squared, we can turn those segments into squares, with areas of a squared and b squared. We want to know how to describe the area if we were to merge these two squares together. Since the quantities of a and b can change, we need to find a pattern for how to break apart this shape. The area of a single square is easier to measure, but two different size squares stuck together is trickier. We can make the situation easier by extending out our shape into one bigger square. To extend the shape into a square, we had to add a length of b onto a and a length of a onto b. The area of this extended square is a plus b times a plus b, or a plus b squared. The original area we're looking for is a plus b squared minus the area we added on. We can slice through this extra area to create two identical rectangles. Each rectangle measures a on one side and b on the other. We have two of these rectangles with an area of a times b. Therefore, we just found that the area of a squared plus b squared is equal to a plus b squared minus 2ab. This will work for any values of a and b. This may have taken a few more steps to see how this identity works, but frankly, the process of finding out why this works is more important than memorizing a formula. Mathematical thinking is not about memorization and blindly following rules. It's about active problem solving and being able to pick apart and deconstruct patterns.